You're welcome to Explore Insights. In this video, I'd like to talk about the binary coded decimal, also known as BCD, subtraction using 9's complement. Now, before I proceed, I would like to make my video brief, so I've considered the case 1 and case 2. So in this video, I just want to focus on case 1. If you're interested in case 2, please watch my subsequent video on that. Now, when I talk about case 1, I'm considering the subtraction of large numbers from small numbers, which I've represented as S being the small number minus L being the large number. And in subtraction technique, it's important for you to know what we call the minor end and the superior end. So in this case, this represents the minor end, whereas this represents the superior end. So I said take note. So the next thing to do is to recall the steps which will help us in taking up a calculation task. So to that, I've written out the 6 steps we're going to take to calculate the BCD subtraction using 9's complement. So let's go with step 1. Step 1 says, take the 9's complement of the superior end. Then whatever you have to add it to the minor end using the BCD addition. Please take note of that. Very important. This is different from my previous video where we will just add the minor end. But when we are talking about the BCD, we have to use the BCD addition when we want to add the value gotten from the 9's complement of the subtraction to the minor end. Then we proceed with step 3, which says that if the result obtained is invalid BCD. Now, when we talk about invalid BCD, it means the value gotten when you sum it up is greater than 9. Now, if it's greater than 9, we are going to correct that by adding 6. Now, 6 in binary is represented as 0110. So we proceed to the next step, which is step 4. Now, in step 4, it says, shift the carry to the next bit. Now, we consider step 5, which says, if end around carry is generated, if it exists, then add it to the result. Meanwhile, if carry is not generated, then the result is said to be negative and in its 9's complement form. And lastly, which is the last step, step 6, we have to take the 9's complement of the result again to achieve the actual result. I know this will look so much for you, so don't worry, I'll take you through an example. So let's start with an example and put in the steps I've mentioned. Okay, so let's look at this example. We are asked to subtract 512.74 from 225.14 using the 9's complement BCD subtraction method. Now, how do we proceed with this? Okay, so the first thing I normally do is to spread out the value first. You need to identify what is the minor end and what is the superior end so that you don't miss your calculation. Okay, so to that, we have the minor end to be 225.14, whereas the superior end to be 512.74. So, having laid that out, we'll proceed with step 1. And our step 1 is to take the 9's complement of the superior end. Like my previous video, whenever we want to subtract to find the 9's complement, we will be subtracting that using 999 for each digit. Okay, so the same thing we are going to inculcate here. So all we are going to do is to check out how many digits do we have and then spread the number of 9's on each of those digits. So to that, we're going to subtract. So we have 9 minus 4 to be 5, 9 minus 7 to be 2, 9 minus 2 to be 7, 9 minus 1 to be 8, 9 minus 5 to be 4. Having gotten this, it's important for us to go ahead to take on the step 2. But meanwhile, I've immediately spread these values in the 4-bit correspondence. What do I mean? In the BCD, we have to convert these values, each of the digits, in the 4 bits. So to that 4 bits literally represents 8421. Now we are going to find out the conversion of 5, which will literally be 0101, because 4 and 1 will give us 5. 2 and 8 were not inclusive, so we turn that as 0, 0. We move over to 2, we can identify 2 here. So we are going to turn that on, while 841 will be zeros. And we proceed to 7. What makes us 7 is the summation of 4, 2, and 1, which we are going to turn on, whereas 8 will be 0. For 8, we can identify 8 here. We are turning that on as 1, while others will be zeros. For 4, like minor, we can identify 4 here, which will be 1, and others will be zeros. So at the end of the day, we are just having this value 0100, 1000, 0111, that's 0010, 0101, 4487.25. Now, let's proceed with step 2. Now, in our step 2, it states that we have to add whatever value we've gotten for the 9th complement of the superend to the minor end. But in this scenario, we are going to use the BCD addition. So take note of that. Now, what do we have as the minor end? It was 225.14. And then this value became the 9th complement of the superend, which in the previous page I've already given you how we converted this value. In the same manner, we're going to convert 225.14. Now, if you want me to explain how I was able to get that conversion, it's very simple. So let me show you that. Now for 4, if we use the 8421, this is the 8421, so 4 can be represented here. So it's 1, while others will be set as zeros. Now for 1, this is the 1, 842 will be set as zeros. Now to identify 5, it will be 0101. Whereas for 2, this is 8421. So the 2 will be turned on as 1, while others will be 0. The same manner this way. Now in this step 2, we are asked to add the both of them, and we are asked to use the BCD addition. So let's see what we are going to have. Now to that, we are adding this. 1 plus 0 will be 1, 0 plus 0 will be 0, 1 plus 1 will be 0 with a carry 1. Remember, the carry 1 is identified with the blue ink here. And then we have 0 plus 0 plus 1 will be 1, 0 plus 1 will be 1, 1 plus 0 will be 1, this will be 0, this will be 0, 1 plus 1 will be 0 carry 1, 1 plus 1 will be 0 carry 1, 1 plus 1 plus 1 will be 1 carry 1, 0 plus 0 will be 0, 0 plus 1 will be 1, 0 plus 0 will be 0, 1 plus 0 will be 1, 0 plus 0 will be 0, 0 plus 1 will be 1, 1 plus 0 will be 1, 0 plus 0 will be 0. So having done that, the next thing we're going to do is to investigate the summation of the 4-bit representative. Okay, so what do I mean that? We're grouping this as 1. Remember, we are dealing with BCD, right? Which is the 4 bits, corresponding 4 bits. So if we add this, it means this is 8, 4, 2, 1. We are going to look at the one that is turned on. So take a look at this. Don't be confused. Be patient about it. Now for the 8, 4, 2, 1, we want to find out the summation. Now, if this is 8, which is turned on as 1, and this is 1, it means 8 plus 1 will give us 9. Now, it means that our 9 is equals to 9. because X is representing this 4 bits, okay? Now let's go to the other side. For this side, if this were 8, 4, 2, 1, it means we have 2 and 1. So that is 2 plus 1 will be 3. So 3 is less than 9. Okay, so let's proceed with the other one. We have here 8, 4, 2, 1. This is 0. We will not be using that. So we'll consider 8 plus 4 plus 1. So that will give us 13. Now compare 13, which is the X, with 9. It means that 13 will be greater than 9. Okay? So let's proceed with this one. So we have 8 plus 0, like 8 plus, this is 4, not important. This is 2 and this is 1. So 8 plus 2 will give us 10. Now 10 represented as X, it means 10 is greater than 9. Let's go to the last one. It says 8, not important. Now the important one will be 4 and 2. So we have 4 plus 2 to be 6. So representing X as 6. So we compare 6 and 9. This value, it means that 6 will be less than 9. Now remember the BCD statement, which says that we can have invalid BCD or valid BCD, but in which condition? Now if S is greater than 9, it becomes invalid BCD. And how can we do that to make it valid? We're going to add 6. So to that end, I'm going to identify which ones were greater than 9. Now you can see here that 6 was less than 9, so it is valid, marked correct. In this case, we have 10 is greater than 9, it becomes invalid. We have here 13 is greater than 9, it becomes invalid. And in this scenario, we have 3 is less than 9, it becomes valid. In this case, we have 9 equals to 9, it is valid. Because our invalid situation stands only for X greater than 9. It means from 10 above, it becomes invalid. Okay, so this takes us to step 3, which says that when it is invalid BCD, we should add 6. That means 0, 1, 1, 0 in its binary form. So this represents 6 and 6. So we are just going to add only 6 to the invalid BCD. Now when we add it, it means others will just be put down. Why this we go on with a summation. So you can see here, I'm just bringing forth those values here. Those values here. But for this one, I'm going to introduce 0, 1, 1, 0, which is the 6 I'm adding. So let's go ahead to add that. So we'll have 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 0 carry 1, 1 plus 0 plus 1, 0 carry 1. So take note, at this point we're going to have 5 bits. So I will talk about this, okay, in step 4. Okay, so let's go with the next summation, adding 6 to this. So we'll have 0 plus 0, 0, 1 plus 1, 0 carry 1, 0 plus 1 plus 1, 0 carry 1, 1 plus 1 plus 0, 0 carry 1. So at the end of the day, we are going to have this also, 1 0 0 0 0, which forms also 5 bits. Now, this takes us to step 4. But before it takes us to step 4, let me tell you what has occurred. You can literally see that in what we have here, this is 4 bits, this is 4 bits, this is 5 bits, this is 5 bits, this is 4 bits. So it's not balanced. So this is why we have step 4. Step 4 says identify if there is carry, and then what do? If there is carry, you move it to the next bit. But how do you know carry exists? Now I'm going to show you. Like I just said, these places had 4 bits, but this place had 5 bits. That's to tell us that carry exists. That means 1 bit extra. So to that, we are going to shift the bit to the next bit. Okay, so we are going to take that carry to the next bit. So what are we going to do? What is that carry? It is this one. We'll just add it to the next bit. This bit here, this starting bit for the next one. Now we're going to take this one to the side. We are adding it. Okay, so when we add it, we are going to have a new figure, which will be, in this case, it will be 1000. Because we're taking this one over here, it will be 1110. Okay, so this becomes the new change we are going to see in step 4. Now, let's go to step 5. Step 5 says, if carry is not generated, then the result is said to be negative and in its 9th complement form. Now, let's see. At this point, we can see through that the bits were sustained as 4 bits each. 4 bits each. So we can say that there is no more carry. So that's to say carry wasn't generated. Now, since carry wasn't generated, we are going to put this result as negative and also keep it in its 9th complement form. Remember where we are coming from? We started with the 9th complement. So it's being sustained in the 9th complement form. So to that, we are going to convert this value to the decimal form because we want to proceed with step 6. So to that, the 8421, we are going to check 8421. 8 and 1 is important. So 8 plus 1 will be 9. 8421, 2111. So 2 plus 1, 3. 8421, only 2 was on, so we have 2. 8421, only 1 was on, so we have 1. 8421, so 421, 4 plus 2 plus 1 was 7. So remember, for this clause, it says the result is said to be negative. So we are going to have minus 712.39. Now let's go to step 6. The reason why I've converted this to decimal form is because I'll be able to understand the given question. Remember, the question was in its decimal form. Okay, so to that, let's move to step 6, where we are to get the actual result. How do we get the actual result? It means we have to take the 9th complement again to get the actual result. So to that, I'm going to take this value and we're going to subtract it from 9. So we have 99999 spread according to the number of these digits. Remember, we are keeping the negative aside because of our result is supposed to be negative plus the value. I hope you understand. I'm trying to say negative with a value because we are subtracting large number from small number. So that's going to give us a negative value. So we are going to take it aside. Now let's see what we are going to have from this. So 9 minus 0 will be 0. 9 minus 3 will be 6. 9 minus 2 will be 7. 9 minus 1 will be 8. 9 minus 7 will be 2. So at the end of the day, our answer is going to be minus 287.60. You can also confirm, before you start calculation like this, I will always encourage you to first of all predict what will be your answer before you proceed with the step. Now, it has been a lengthy topic, but I would like to stop here. So today we talked about the BCD subtraction using the 9th complement, and I was able to take you through the steps and also with an example. So I hope you enjoyed the video. Do well to watch my subsequent videos and my previous videos as I take you through this course on digital electronics. Thank you so much for watching, and thank you so much for tuning into Digital Explore Insights. Now, I'll be signing off now. Do have a nice time. Enjoy. Bye.